So for this first one, for times 0 to 10, water is flowing into a small tub at a rate given by this function. They never give nice functions on the AP exam. They're always crazy, weird ones. So just, get on board because they're never going to give you something nice. It's always going to be something that's a pain in the butt to type in. But anyway, that is the rate in. So let me write myself a note over here. That is the rate in is f of t. And it is from 0 to 10. So water is flowing into this tub like a tank. Think of it like a fish tank at that rate. And next sentence, all right, for times 5 to 10, so starting at time 5, water starts leaking out. So it gets a hole in it or something at a rate given by function L of t. So the rate out is L of t. But that's only from 5 to 10. So water only starts leaking out after 5, what was the time in it? Minutes? After 5 minutes has gone by. So water flows in for 5 minutes, and then at 5 minutes it starts also leaking out. So there's 2 rates going on here. But those are rates, so those are derivatives, since that's the rate of the water. And it says that they're both measured in cubic feet per minute. So feet cubed per minute. Again, that shows you it's a rate, something per something else. Volume in cubic feet is given by W of t, which they don't give us at all. We don't have that. All we have are the rates. We don't have the actual amount. All right, so letter A, it says at time 3, there are 2.5 cubic feet of water in the tub. Write an equation. Ooh, hey guys, what 2 things do I need to write an equation? Weight and slope. I think I ask you guys that like at least once per class. Do you get like how important that is? That's just huge in calculus. Write an equation. We need a point and a slope. And then they throw a lot of vocabulary at you for the local linear approximation at 3. It's like, yeah, you told us at time 3. So they gave us the point. It's 3, 2.5. That's our point. At time 3, there's 2.5 cubic feet of water. Use it to approximate the volume of water at time 3.5. So remember, we're allowed to do an approximation as long as it's really close to the point of tangency. So if we're writing this at 3.5 is what they're asking us to plug in. I'd rather it was a little closer, but anyway, we're going to do that approximation. All right, the slope is the rate. So these are our rate functions. We just need to get this at time 3. Now here's the thing that's tricky. Usually it's rate in minus rate out. But we're only going to need to use the rate in. I will not need the rate out equation at all. Why not? Why will I only need rate in, but I will not need the rate at which it's leaking? Why can I like kind of ignore the rate out? Yeah, well, it would be 3 is less than, I get what you're saying there. We're writing this at 3, but you're exactly correct. It's less than 5. We haven't gotten to a point where the water's leaking out yet. The water doesn't start leaking out until 5 minutes, and we're talking about 3 minutes. So 3 is less than 5, so perfect. So we only need the water flowing in. So we're gonna do this rate, this f function at time 3. And see what we get. And here's where the calculator is going to come in because this is a crazy weird function. And we're going to plug in 3. So arc tangent. Now they wrote it was arc, but that is the tangent inverse. So it's going to be second tangent, the tangent with the little -1 there. So second tangent. And then we have pi over 2. Oh, whoops. All right, pi over 2 minus, and we're plugging in 3 for t. So this is 3 over 10. And we get 0.904 for our slope. Again, slope means the rate. That was the rate of the water going in at time 3. So 0.904. And then we're going to write the equation. So now you can use x and y. They actually won't take off for that. But for this one, it's W for the water and T for time. So I'm going to use W minus 2.5 equals the slope, and then T minus 3. Again, if you forgot and put X and Y, that is totally fine. I would not mark that wrong. They would not mark that wrong. It's just this was for the amount of water and then time. And then the only other thing we have to do is they wanted an approximation for time 3.5. So we're going to plug in 3.5 for time, and we just have to get W by itself. So I'm going to add this to the other side. And you do not have to simplify any of this down. In fact, I recommend that you don't. But we do have to put units at the end because this was a word problem. So this is an actual amount of water. It's water equals, and so that was in cubic feet. So whatever that number is, cubic feet. All right, we're just going to do one more on the front of this paper. I'm going to do letter D, because this is the one that's a related rate. So D says the tub is in the shape of a rectangular box. So you want to think like a really big fish tank. So it's in the shape of a rectangular box like this. It's pretty good. I don't know. Use your imagination. It is 1 foot wide and 4 feet long. And what does it say? 3 feet deep. Yeah, and someone just typed, you can't see it because it was to me privately, that last one looked more complicated than it was. That is the story of the AP exam. They are going to throw so much information at you and so much vocabulary. And then what you actually have to do is not really all that complicated. So you need to hold on to words that like make sense, because it's going to be stressful when you go in there to take it. So when you see equation, like that's a simple word that we know what that means. You want to think point and slope. That's why I keep trying to bring that up so much. And once you see that, if you go, hey, I just need a point and a slope, that'll calm you down, because you'll be like, oh, well, they gave me a point. I have that. And then, you know, slope means rate. So they gave me that, you know, and then you can start trying to piece it together. But they're just going to slam you with information, left, right, and center. And you have to kind of sift through what they gave you and what you actually like need. And yeah, towards the end of the year, we're going to do so much more AP practice. So don't worry, we're gonna do that. But I'm trying to do it a little bit each unit as we go along, which is why we're doing these problems. All right, so this is the tank. It was 1 foot wide, 4 feet long, 3 feet high. What is the rate of change of the depth of the water? Right, so this is the water in the tank. So the tank itself is not changing size. It's not like a magical growing tank, but the water in it, that is changing. So we are going to write an equation for the depth of the water, or the volume of the water. So volume would be length times width times height. So that's going to be 4 times 0.5 times the height of the water. We actually end up not using the 3. We don't really need the height of the tank. We just need the height of the water in the tank, which is a variable that's changing because water's flowing in and water's flowing out. Because there's like a hole somewhere in here and water is like leaking. All right, so volume is 4 times a half is 2. So just to simplify that down. And then this is one of the easiest derivatives you could ever hope to be asked for. dV dt equals 2 dH dt. And what they're asking for is the dH dt. They want the rate of change of the depth of the water. So this is what we're trying to find. We need to go back and get the rate of change for the volume. Now this is at time 6. So since 6 is bigger than 5, we now need both of these. We have a rate in minus a rate out. That will give us the rate of change of the volume, the dV dt. So rate in minus rate out. So this dV dt is going to be f of 6 minus L of 6. And then I'm just going to go ahead and divide over the 2. We'll divide over that 2 to get the dH dt by itself. And I'm just going to need to plug that in my calculator. And it's not going to be fun. It's going to be real messy. Okay. And again, I just divided this 2 over. We're plugging in 6. They said at time 6. I already have this right here. What I'm going to do is just go and bring it back and change the 3 to a 6. So I don't have to type that all over again. Because I already typed it for time 3, and I just went and changed the 3 to a 6. So I don't have to type it all over again. So that's the rate in, that's the f of 6, minus, and then we want to do L of 6. So let me pull this back down here. Here's L. So this is 0.03, parenthesis, 20 times 6, minus 6 squared, minus 75, close parenthesis. And when I hit enter here, that's going to give me that rate. So that was the f of 6 minus L of 6. And then I just have to divide that by 2 to get my final answer. Again, I just divided that 2 to the other side. So I'm going to hit divided by 2. And that is our final answer. So 0.250. And make sure you write the 0. You need 3 decimal points. Like if you just put this, they would not give you they wouldn't give it to you. You can feel however you want to feel about that. They will not give it to you. And then we do need units. This was a rate of change for the height, so feet per minute. It is not cubed because the cubed was for the rate of the volume. This is just the rate of a height, so just feet per minute. And then we're just going to do a couple of the ones on the back. We're going to do a few of these. We'll do the multiple choice ones because they'll go kind of quick. Number 3, oil is spilled on a floor, unfortunately. The area for the oil is A, so A for area. We've got square centimeters, we've got seconds. That actually doesn't come into play because they didn't put units here. Which of the following gives the rate at which the area is changing? Well, rate would be a derivative, and there's only one choice here that has that. It would be D, A prime of 10. That's the rate at which the area is changing, would be A prime, and they said at 10. All right, number 4. A rectangle has a width W and a height H. The width is twice the height, so width is going to be 2H. They're both functions of time measured in seconds. A represents area, which gives the rate of change of area with respect to time. So before I even start doing any math here, we can eliminate 2 of the choices. This is a rate for an area. So look at the units that they gave. Which 2 choices can we narrow it down to? Like which 2 choices could it be? If it's an area, look at the units. Yeah, A and C aren't squared. Good, nice. So we can automatically just, right away, before I even do the problem, it's going to have to be one of these. All right. Now, they do not give you area of a rectangle. They would not give you that. You'd have to know that. It would be width times height. I know it's like length times height or base times height, but they used W and H here, so that's what I'm going with. And we're going to plug in 2H for the width. And so the area would be 2H squared. And then we just have to do that derivative. So dA dt equals, this would be 4H dH dt. And so that one is D. All right, number 5, which of the following limits does not yield an indeterminate form? So that means 0 over 0 or infinity over infinity. So it's which one does not come out to that. All right, so this one, if we plug in 0, numerator will be 0. Down here, sine of 0 is 0. So this one goes to 0 over 0. For letter B, if we plug in 2, 2 over 2 is 1. ln of 1 is 0. And you would need to know that without a calculator. ln of 1 is 0. And down here, if you plug in 2, you're going to get 0. So this one goes to 0 over 0. Here, if we plug in pi, pi minus pi is 0. Cosine of pi is not 0, though. Here's our unit circle. Pi is right here. Cosine is the x value, so that's -1. So cosine of pi is -1. So that one does not come out to indeterminate. So that one is our answer. But I'm still just going to look at D real quick. You can't plug in infinity, that's not a thing, but we're gonna do it anyway. If you plug in an enormous number here, exponential to a really enormous number, that's gonna go to infinity. And a really enormous number to the 100th power is gonna go to infinity. So that one is also indeterminate. And then last one here, I'm sorry, I typed these in the wrong spot, so I just hand wrote it to fix it on here. It says selected values of this twice differentiable function, functions f and g, and their derivatives are given. We want this limit. So first thing you want to do is plug in 3. So 3 cubed would be 27. And then times f of 3. So f of 3 is 2. And then minus 54. And then down here, g of 3 is 1. And then minus 1. So you get 54 minus 54 over 1 minus 1. It goes to form 0 over 0. So we're going to do L'Hopital's rule here for this. So this will be limit as x goes to 3. We are going to need a product rule for this first part. X cubed is the first function. F of x is the second function. So it would be first times derivative of the second plus the second times derivative of the first. And then minus 54 is a constant, so that is gone. And then down here, derivative of g is g prime, and then 1 is a constant, so that's gone. I know it looks like we made it more complicated with this product rule in here, but at least this time we won't get 0 over 0. So let's try plugging in 3. 3 cubed is 27. F prime of 3. So f prime of 3 is negative 4 plus f of 3 is 2. And then if you plug in 3 here, 3 squared is 9 times 3 is 27. And then g prime of 3 is 2. Now, if you had to get through this without a calculator, what I would do, and you could do 27 times negative 4 and work that out. What I would do though is notice both of these have a 27. I would actually just factor out the 27. I would just do a GCF with that. If you take out 27, you're going to be left with negative 4 plus 2. If you don't have a calculator, which this would be a non-calculator problem, you'd have to get through this somehow. So that's what I would do. I think that makes this a little bit easier. Negative 4 plus 2, that would be negative 2. The 2's are going to cancel, and so we get negative 27. And so that one is C.